Hello, this is our first example for the normal curve. Reading along, the height of male students in universities is normally distributed with a mean of 170 centimeters and a standard deviation of 8 centimeters. The most important thing that you can do when you're doing this type of thing is to set up your normal curve. So you see I already have a normal curve. So in the normal curve, we know that it already should have an x-bar. That's in the dead center, and our x-bar is 170. With it then, there are 1, 2, 3 spaces to the right, and 1, 2, 3 spaces to the left. So though you may not have this diagram, draw the diagram. It can look sloppy, ugly, as long as it looks normal-ish, and it has these 1, 2, 3 on both sides. We're told the standard deviation is 8. So I'm going to go ahead and write down the standard deviation plus the mean. So 8 plus 170 means that line is 178. That means this line is 186, and then the final one is 194. Going in the alternate direction, I subtract 8 and continue onwards. So 162, 154, and 146. So now I've got this curve set up. I'm going to go ahead and answer each of the questions. Some of them are going to be easy, and then some of them are going to be a little bit more challenging. So in letter A, it says find the percentage of male students whose height is between 162 and 170 degrees. If you wanted to color this in, you don't have to do this each time, but I could say here's 162, here's 170, and it's going to be everything in between this. But more importantly, what I want to note is, if we get back out of there, if this is our neutral point 0, and this is where we're going to really get at with putting stuff in, then 178 is 1 standard deviation above, 186 is 2 standard deviations above, and 194 is 3 standard deviations above. The left-hand side goes -1, -2, and -3 likewise. So when I go into my calculator, as per the calculator notes, or if we do not have a calculator, you can do this using the reference table from the A2 trig exam. I'm going to go ahead and want to get this between -1 and 0 for the space on the normal curve. So if you're doing this in the calculator for part 1, you can go ahead and just get by doing the second vars and then getting the normal CDF, not P, CDF, put in your left bound, which we said is -1, your right bound, which we said was 0. If you're doing this using the reference table, find all locations where it's between, so it should be there are 2 little bars between -1 and 0. And whether you use the calculator or you're getting the reference table, it should be something to roughly a 0.3413. Now this question, it asked me for the percentage, so we would have to multiply that by 100. The 34.13%. I'm rounding, but you can go ahead and do like our typical, what we've been doing in statistics, hundredths place. I will recommend, if it is just as a decimal, the 0.3413, go out 4 digits instead of going out to 3. I always say that so that when it's a percentage, we can be able to get it into the hundredth place spot. There we go. All right, let's extend the page and look at part 2. So I want you to try part 2. We're going to have the video pause. Now part 2 is between 170 and 186. You don't need to go ahead and solve the whole thing yet, but I want you to try to identify what are the 2 boundaries. What's the lower bound and the upper bound? Pause the video and take a second. Hi, between 170 and 186, that's what you're looking for. So if you look at it, 170 is my 0 spot. So I'm going to put 0 down for my left boundary, and 186 is 2 standard deviations above. So by either, again, finding this on the reference table or hopefully calculating it, we get the answer to be 0.4772, and again, rounding to, changing to converting to a percentage, we've got it as a 47.72%. All right, let's go ahead and now look at this from the perspective of just probability. Now it asks me for this as a probability, but we know probabilities really are percentages. So if it says probability, it's the same exact thing. So I'm going to put a line there, and then note, for letter B, it wants this between 178 and 186. So this is exactly the same. I'm going to start with my normal CDF, and then just note 178 is 1 above, 186 is 2 above. Convert, we get a 0.1359, and remembering our probability unit, you may leave it like this. Go on to number 2, less than 162. So we have yet to see one like this. I'm going to walk you through this one then as well. And let's spell normal, right? Normal CDF. Now I'm going to first start with the 162 part, because you can see on the diagram above that this is -1 for the right-hand side. The left-hand side is tough. So what I suggest is you type in a really, really big negative number. So if you want to do something such as, say, -100, something like that, it's going to just be a large enough number such that it will be fooling the calculator into thinking it goes onwards forever in the left-hand direction. So this is challenging with the reference table. With the reference table, you have to, and let's even just scroll back to the reference table, you have to include not just, we were at -1, this part, this part, this part, and this part, but that sliver of 0.1%, which you see here in your final answer. This really won't affect things for the most part, but to make sure that we don't make any mistakes, do include that in all future calculations. So when you go ahead and add those up, it should give you a 0.1587 and then give you your final answer. So let's go ahead and try this, but also with numbers 2 or 3 and 4. So like before, I'm going to pause or ask you to pause the video and have you go ahead and come up with the left-hand and right-hand boundaries. Welcome back. So for number 3, it says less than 154. 154 is at -2, so that's my right-hand bound. And then I'm continuing to go down forever, so let's try -100. If you wanted to be a wise guy and do -99 or do -5024, something like that, you're fine. Just remember, it's a big negative number. For number 4, greater than 162. 162 is this time the left-hand bound at -1, and I want now a positive large number. If we just stick with 100, we can't really go wrong. We'll put those in there, and then by pressing the button to enter this into my calculator, or by going ahead and doing this on the reference table, please again pause the video and try to attempt at getting one of these values, and then check in with us once you're done. Welcome back. Hopefully you got something close to, if not exactly, these two numbers in green, 0.0228 and 0.8413. We can go ahead and join us now to the next video. Go ahead to that one, and we will see you for the next example.